Welcome to This Explainer. Today, we're diving into a deeply tragic and honestly incredibly mysterious aviation case. We're looking at the final flight of a Cessna 172, registration VT-CAI. Now, this was supposed to be just a routine training flight on a perfectly clear April morning back in 2009. But instead, it turned into an absolute aviation enigma. It took weeks just to locate the plane and months to finally piece together what went wrong. The investigation that followed reads exactly like a detective novel, complete with red herrings, hidden mechanical flaws, and a terrifying chain reaction of catastrophic failures.
Right off the bat, the official report contains this incredibly striking detail. The relatives of the deceased student pilot, along with the villager and private divers, retrieved the wreckage on May 29, 2009, by using a balloon to lift the wreckage. Think about that for a second. This wasn't a typical crash site where investigators could just walk up and tape off the area. This aircraft ended up at the absolute bottom of a massive dam and remained completely lost for nearly 2 months. It left a grieving family in agonizing suspense and an entire aviation community scratching their heads, wondering how a perfectly normal flight could just vanish into the murky depths. Section 1. The solo flight. Let's look at how this routine morning started, because at first, absolutely nothing seemed out of the ordinary. Okay, let's dive into this. The pilot was a 19-year-old student who was just building his hours for a commercial pilot license. He was tasked with a 332 nautical mile solo cross-country flight. The planned route was a simple triangle, departing from the Dana airstrip, heading east to overfly Omiria, turning south to Bihar, and then finally returning home to Dana. And the aircraft itself? VT-CAI had actually just completed a flawless 4-hour flight earlier that very same morning with a totally different student. It was refueled, it was inspected, and it was ready to go. If we walk through the timeline of the morning, it really emphasizes just how routine everything was, until suddenly it wasn't. Takeoff was at 0815 UTC. At 0925, he radioed in over Amiria, right on schedule. At 1020, he reported over Bihar, making his final turn for home. His last radio contact was at 1050 UTC, reporting 85 nautical miles inbound to Dana. But when his estimated time of arrival of 1150 UTC came and went, the radio was just dead silent. He was officially declared overdue, and a massive search was immediately kicked off. Section 2. A 54-day search. That sudden, eerie silence marked the beginning of a grueling and heartbreaking chapter. The truth is, the aircraft never made it back to Dana. Instead, it deviated about 10 kilometers to the right of its intended track, placing it directly over the massive Bargi Dam. Now, witnesses on the ground reported seeing the aircraft approaching the water from the east, making a really low pass, and then inexplicably looping around for a second pass. On that second approach, flying precariously low, the aircraft actually touched the water, tipped over, and sank almost instantly with a loud bang and a massive splash. Local fishermen desperately rushed over trying to hook a rope to it, but it sank way too fast. All they could do was leave a buoy bobbing on the surface to mark the spot. But knowing roughly where the aircraft went down and actually recovering it, those proved to be two entirely different challenges. The district administration brought in a team of highly trained Navy divers, but the environment down there was incredibly hostile. We're talking 100-foot depths and a floor covered in massive submerged trees. After 8 agonizing days, the Navy team had no choice but to call off the search. But, the pilot's parents absolutely refused to give up. They literally camped out at a nearby village for nearly 2 months. They eventually hired private divers, and finally, working alongside local villagers, they miraculously located the aircraft 54 days later on May 28th. So, to finally bring VT-CAI back up to the surface, the recovery team had to get creative. They attached a large, heavy-duty Sea-Flex balloon to the submerged wreckage, pumping it full of air to literally lift the mangled Cessna right off the waterbed. It was a massive physical undertaking that finally brought some much-needed closure to the search effort, but of course, it opened up a completely new phase of the story. Because now, with the wreckage sitting right there on the shore, the human tragedy gave way to a complex forensic puzzle. Investigators were staring at this mangled pile of metal, and they were facing one massive question: what actually caused the crash? Why on earth would a plane on a perfectly routine flight, in good weather, suddenly deviate off course and crash into a dam? Section 3. Analyzing the wreckage. Let's look at the clues, stepping right into the shoes of the detectives. Right away, they saw that the water impact was totally devastating. The forward fuselage and the engine bay were heavily crushed, with the engine itself just barely hanging on by its lower attachments. Tragically, the postmortem and the cabin analysis revealed that the young pilot had actually survived the initial impact. He had desperately tried to escape, moving toward the rear of the cabin as the nose began filling with water, but tragically, the doors remained jammed closed. But the physical clues left behind tell a really interesting story. The engine mount was broken and the propeller was severely twisted, which absolutely proves the engine was spinning fast when it hit the water. The throttle was pushed full in and the fuel selector was set to both, meaning the pilot was likely trying everything he could to maintain power. But then, investigators found something totally bizarre, a distinct layer of black soot deposited all over the top half of the firewall. Now, there was no post-impact fire because the plane sank instantly. So where in the world did this superficial fire and soot come from before the crash? Section 4, the engine investigation. To figure out if the engine had failed or caught fire in mid-air, they shipped the whole thing to a specialized facility in Bengaluru. The investigators there were incredibly meticulous. Step 1, they systematically disassembled the core and confirmed the main power section rotated totally freely. Step 2, they checked the connecting rods and the entire lubrication system. Result? Absolutely zero sign of oil starvation. Step 3, they bench tested the fuel flow divider, the fuel nozzles, and the manual mixture controls. And guess what? Everything tested completely normal and well within specification. So the crucial takeaway here is this. The final verdict was a resounding no fault found. All the accessories were perfectly operable. The engine was just humming along normally at the exact time of impact. The engine itself was a massive red herring in this investigation. It didn't fail. Something else entirely drove this plane into the water. Section 5, the starter mystery. Let's enter the final phase of this investigation, where the real culprit is finally exposed. Investigators began digging through the maintenance logs, and a highly suspicious timeline started to emerge. The aircraft's original starter had logged almost 700 hours without a single hiccup. But on April 5th, literally the very day before the crash, a brand new starter had been installed. The aircraft flew just one snag-free sortie on the morning of April 6th with that shiny new starter. On its very second flight, it crashed. I mean, that timing is just way too coincidental to ignore, right? So they pulled the electrical junction box and finally found their culprit, a contactor. Now, this is essentially a heavy-duty electrical switch, also known as a solenoid, that sends power directly to the starter. When the investigators cracked it open, they found the solenoid plunger and its spring were heavily corroded, and the internal contacts were totally blackened. It had failed. But more specifically, it had failed and stuck in the closed position. And this brilliantly illustrates the catastrophic electrical chain reaction that followed. When that contactor stuck closed, even after the pilot started the engine and let go of the ignition key, the starter just kept receiving power. But because the engine was already running at high speed, the starter was physically jammed, drawing massive continuous current while essentially at a standstill. The internal armature burned up right at the brushes. The heavy cables connecting to the starter began to severely overheat, literally baking their protective sleeves. This intense, localized electrical overheating is exactly what caused that distinct black soot and the terrifying smell of fire on the firewall, which almost certainly panicked the young pilot and led to that fatal deviation over the dam. You can see the physical proof of this terrifying electrical event right here. We've got the burnt positive terminal cable and the heavily scorched, destroyed starter armature components. This wasn't just some minor electrical glitch. This was a heavy-duty component quite literally baking itself to death under the cowl while the pilot was miles and miles away from home. The specific part involved in all this was a Skytech Model 149 NL starter. Interestingly, this was introduced as a product improvement for this model of aircraft. But as the investigators dug even deeper into the data, they realized something terrifying. This was not an isolated freak accident. The official report revealed a truly chilling detail. The starter manufacturer was already fully aware of frequent failures on these specific aircraft. Their own factory analysis of returned starters consistently showed a burned metal smell and totally destroyed internal components. The probable cause across the board? The aircraft's starter solenoid arcing, welding itself shut, and remaining stuck closed, exactly like what we just saw with VT-CAI. It was a completely known vulnerability in the electrical architecture of 12-volt and 24-volt Cessnas of that era. Which leaves us with a pretty haunting thought to conclude this explainer. The mystery of Bargy Dam was finally solved. It wasn't pilot error, and it wasn't a catastrophic mid-air engine failure. It was just a tiny, stuck electrical solenoid that triggered a fatal chain reaction.
But if this was a known issue causing starters to continually burn up, we really have to ask ourselves. An engaged starter caused a catastrophic electrical failure here, but how many other aircraft might be flying with this exact vulnerability right now? Thank you for joining me for this explainer, and keep your eyes on the skies and definitely on the details beneath the cowling.